Hi. So this is the demo for the turning your Android phone into Ubuntu Linux-based IoT for our group. So what I'll be doing is that I'll try to go through the presentation and try to show as much as I can in the phones that we worked with to show you, to get you through the demo for today. So moving on. So the first thing is something actually quite interesting. So we basically have like three phones here, and this one's like a Nexus 4. This one is a OnePlus 2, and this one's a Redmi. And we try to work with all three of these phones, trying to work out different configurations to figure out which one would suit best, because we were also looking into our project and the extension of all of this into our project to use. And we figured that the Nexus 4 worked out best for us, and that is where we were able to, go through all the steps without any issues. So while running through the demo, I'll show you what roadblocks we faced in these different phones that we try to use, and why we went on with Nexus 4. So the first step was obviously the installation of the Ubuntu Touch OS onto the phone, and for that we basically had to unlock the bootloader. And after the bootloader unlock, we basically had to run the installation file for Ubuntu Touch and let it go through. So for this, the first part was going into the phone, and let me just show you this. So if you can see here in the About phone, you basically go into the build name, which is the mini version here. So here, if you tap like a few times, 7 times to be precise, you basically get a message which says no need, you're already a developer. So if that is not there, then basically to enable the developer options, you have to tap on the build number a few times. I'm sure like a lot of people would have already done that, but I do remember that it was specifically said that this was supposed to be instructional for the people coming in the later labs after us. So I tried to be as descriptive as possible with the installation of Ubuntu Touch and a few other steps on the slides. And you can see that there would be all slides, like all steps that are mentioned for different phones, so that it can be picked up later. So in the additional settings here, you'll probably see the developer options. So before moving ahead, what we need to do is that we need to enable the OEM unlocking option here, which is this one. So I've unlocked the OEM option. And the other one was USB debugging, the two USB debugging options. So we have to enable that so that we're able to, connect the device to the PC. And once the enable debugging option is present, then you basically get like a message inside this to trust the machine. And when does that happen is if I go to this and I say ADB devices. And for this, obviously, you need to install ADB through the Android tools. And I've also added a link along with this for you to be able to do this on Windows or Mac. So here, if you see, when I run the ADB devices, you see that the device that is attached right now, the Redmi, is actually being detected. So once all the options are enabled, what we do is we basically start the OEM unlocking. And for that, let me just go to the slide so that I can just copy paste out of it as well. So the first part was obviously loading the phone in the reboot bootloader option. So I'm going to do that. So when I run ADB reboot bootloader, the phone actually goes into the fast boot mode, which you can see here. So this is the fast boot mode of the Android. And here, if you say fast boot devices, you'd be able to see the devices that are attached to this. Right now, it's not showing because of the driver issue for MI. So yeah, basically this was where we started facing issues. And when we started with Redmi, we realized that Redmi actually needs something called the MI unlock. And using the MI unlock, you need to request like an unlocking of your phone, and that takes like a whole 7 days for the process to go through. So and by that time, I think our Nexus 4 arrived and we started working with that instead. And before that, we obviously moved on to OnePlus 2. And OnePlus 2, I was able to install Ubuntu Touch, and it all goes through, everything looks good. But at a later point of time, I'll tell you what went wrong with OnePlus 2 and why we did not use it any further. So this was the part about OEM unlocking. And once the OEM unlocking was done, we basically started off the Ubuntu installer and we downloaded the particular installer file online. And once that was done, we went into applications and started off the Ubuntu installer. And the Ubuntu installer is basically able to take care of all the steps in the installation right from the start. So you don't have to go too far or try too hard to, uh, start the installation files. So yep, this is the Ubuntu installer. So here, once your device is enabled and it is connected to the device, then it will basically auto detect it, and then you can auto install all the steps from it. The only thing you need to be careful about is to make sure that you download the Ubuntu installer for the right phone, because for each phone you have like different configurations, and it is advisable that you look into the feature usability before trying your phone, because for Nexus 4, not a lot of information was available. For OnePlus 6, there was, but the phones that we used, for example, the OnePlus 2, let me go look for OnePlus 2. So in OnePlus 2, the issue that we faced was in MTP and ADB access. And it was already found out, like it was already written in the page that these two things were not available. So it might be it might be useful for you to check this page once to see what is supported with your phone and what is not. At least we know for sure that Nexus 4 works with everything. So that is a comfortable and safe option for everyone to go with as well. So you download the appropriate version of the installer, and depending on the installer, you have Ubuntu Touch on your phone once that is installed. So I'll just move ahead to the next bit of the presentation, which would be the OS installation. This part I've already talked about. So I'll move on to the SSH bit, and for that I'll first connect the Nexus 4 that I have to my PC. And once I do that, you will see that I'd be able to detect. So this is how the OS looks. It was actually very fun to, go around and try and understand how this works, and how to close an application. Everything was fairly different than as new. And I think the coolest thing in this was for me to be able to look at terminal. So yeah, like I really had fun playing around with the terminal and trying to see that work out on the phone. So it was fairly nice to see the terminal, and this was also an indicator of what I might need to look into when I SSH into the terminal from my machine. So yeah, so here you see, for example, when my Nexus is connected, my Ubuntu the Touch installer automatically detected that my Nexus 4 make is attached to the device, and I can install Ubuntu Touch for it. So if I run an install on this, then it would be able to install the Ubuntu Touch. So anyway, moving ahead, let me just check for the ADB devices, and yep, so my device is visible, so I'd be able to SSH to it. So let me look for all the commands. We actually have something of a Slack channel where we keep track of all the commands. So these commands are the same as the ones that you can see on the presentation. I'm just going to copy all of these and run you through what each one of these does. So in this one, first one is obviously to enable the developer mode. So you need to do that in Ubuntu Touch as well. So within the settings, you would basically find the advanced systems. Let me just show you that. So this is the settings opening up. So in the settings, if you go to about, and in the in about you go to developer mode, you basically see like a Dropbox. If you enable this drag box and click it, like keep it enabled along with the passkey, then you basically are able to use ADB devices and debugging mode on the Nexus for you to be able to work with Ubuntu Touch and SSH into it. You won't be able to SSH without it. So to be able to SSH, what we also need to do is create our own keygen. So this is being done by the SSH keygen minus TRSA. We have already done this because we have SSH'd a bunch of times. And then the ADB shell. So every ADB command is basically running on the phone. So here we're basically just making an SSH directory for like within the phone. And once that is done, we're basically copying the ADB push basically copies the SSH ID from our local machines onto the SSH folder of the phone, and then provides all the particular permissions that you need to get it working. And every time that you switch from one machine to another, all you need to do is just push and then run these three commands to provide access, and then run this particular command to enable the SSH. So let me just do that. So the first one is that I enable the SSH. So it says SSH is enabled. The next part is this directory already exists because I created it. The next part is that I push the file. So this file was pushed. And then I provide all the access commands for permission. First one, second one, and the third. So now that my SSH has all access options, the next part is to find out the IP address. And when we're looking at the IP address, the one thing that we need to make sure is that both the laptop and the phone are connected to the same network. So this is the IP address. So I just copy it. And here is it is SSH or SSH. Yep. So it should already be there. Let me just make sure it's the right one. So here I had provided like a passphrase for my own SSH in my machine. So I just added that, and here you can see that I have SSH'd into the system, and the same console that I see here is now, so here the same console that I see here is also seen on my screen. So I have actually SSH'd into the machine via the internet. So for the disabled GUI, this part would be handled by Parth, and he'll show you how like the commands being run to stop the GUI. So when we did stop the GUI, the first step was that when we turn off the when we turn off an Ubuntu phone, and then like after the first three commands, what happened was that we were able to disable the screen, and that screen came onto the Ubuntu touch screen, the basically the home screen. And this was this still took some power, and for us to further stop the services, we had to run a few more commands to completely disable the GUI and like have no screen. But then like we found out that at that point of time it was very hard to understand what was happening in our phone, and we had to actually restart. So this is the screen that you see when you run the sudo service stop, and you stop the different services. So yeah, like after that, what we realized was that if we were stuck at any point of time and those services were not working, we were able to retrieve the display back after a simple reboot of the phone. I'll just like I've left the commands here, and I'll just like not go through the demo to make sure that it takes lesser time. And yep, the one thing I can do, however, is show you how I was able to check for All right. So another thing was the enabling of speaker and recording audio. So for this, what we first did was try to see if the speakers on our phone was working after adding Ubuntu Touch, and we found out that we were not able to listen to any sound, and the microphone wasn't working either. So the first thing that we did was to try out different drivers, and we finally got the speaker to be working after the addition of all of this. And apart from that, there were other parts that parts would be explaining as well. So for the recording of the audio, we basically use this command a record -d10 -f dat, and this is the audio output file name. And when we did this recording for 5 seconds, we basically had like an audio file that was stored onto the phone. So for that, let me go and see where it was. But what we did afterwards was we basically SCP'd we SCP'd the file away from this phone. Yeah. So here, if you see, we basically use the SCP command to take out the file from home phablet. So let me go to cd/home/ and then ls. So here you'd see the audio and audio one wave, and then there was audio two wave as well, which is on the desktop. So if I play this, you'll basically find that, wait, open with VLC. Testing, testing, testing for Nexus. Yep. So this was the output audio from this. And do note that we had to use earphones for this because the regular phone recording wasn't working. And yep, that would be all about phone recording. All right, so let's show you how the changing for clock speed worked. So for this, again, we basically went through the available governors. I'll just run this command on the machine once. So like I'm already SSH'd into the machine, like into the phone. And here what I'm doing, the first command that I have shown you is to check for all the available governors in the phone. So it was actually interesting to go through the documents for Android and look into for Ubuntu Touch actually, and look into the how the different governors used to work, and how through those governors you can basically set the clock speed to different parts. So by default, when we had our Nexus, we started off and we found out that like we can basically check which particular scaling governor is being like which particular governor is being used right now. So let me just find the command for that. Where is that one? Yep. So this particular link basically gave us like a lot of description on which particular governor, like which particular commands like we can use and which governors we can use, and each of those governors have like different advantages. For example, in the power save one, it basically picks up like the lowest the lowest frequency of the available ones. In the performance one, it basically picks out the highest frequency among the range that you basically set for it. And in user space, you're basically able to customize the governor's frequency a little bit more. And in the interactive one, it is basically more optimized to, get your phone like into like a more heavy duty performance mode. So we basically started off with the user space mode. So what we did was we first set this to user space, and that we did by, wait, so oh, okay, so I had to log in as a root, and here I basically give out my phone tablet number, and yep, so oh, we are, yep. So when I do this, so basically my governor has been set to user space, and if I just do this, I think I'd be able to see. No. See. You pick ls. So in this, basically, you're able to see all the different options that are available. And here you can basically check the current scaling frequency that is being used. So for example, in the on-demand, what it does is that it sets the clock frequencies to whatever is needed by the phone. So to check whether the clock frequencies that we set were actually working or not, we basically use this command, which is the watch current frequency. So let me just show you this. So for example, this one would be, yeah, scaling governor. So if I do cat scaling governor, I'm able to see which particular governor is active right now. And if I say cat scaling cur underscore frequency, and then I do a watch on it. So here what it is doing is that it will keep changing every 2 seconds. And right now it is set to the lowest clock frequency, and I'll show you why. However, if we set this back on demand, you'll see this particular frequency changing consistently from this value all the way till 1512000. That was what we saw before we set the whole thing. So here, if you see that in each of these, like you can see the scaling max frequency. So for this particular user, if you see the scaling max frequency and scaling min frequency, you can see that the clock frequency will be scaled between whatever values you set for max and min. And those values can be set using this. So when I ran this particular command, what happened was that cat scaling max frequency. So here you can see it is right now set at 1512000, and when I run this, I can basically limit my phone's performance by setting it out, and here you can see it is 400,000. And when this happens, your phone really starts dying out. Look at the performance now. So when I actually start trying to work with it, it reacts very slowly because I have basically limited on the clock performance, and the phone becomes very laggy. So it is always essential for me to, go back and check, because this actually happened once or twice. We worked on this and we forgot to turn back the clock frequencies after experimenting around with it. And then we couldn't turn on our phone, and like it took us a while to, put it back together with the SSH. So yep, that was fun. So yep, so now the scaling frequency is back to normal, and you can see that the phone will also respond to it, and probably, yep, think it needs a restart right now. But yeah, like the phone basically is more responsive once the scaling frequency is set back to normal. And yeah, the other part is obviously checking for the CPUs. And yeah, this one part I've already talked about, the watching of the current frequencies. Now for the core disabling, what you can see here is that right now we are in this particular directory. So it says devices, system, CPU, CPU0, CPU frick. So if I go back one folder and another one, and then do an ls, then here actually you see CPU0, CPU1, CPU2, and CPU3. So these are the 4 CPUs that are available to the phone, because this phone has like 4 cores. And you can basically check that each of these commands that I have given in the slides all have CPU star. So when I'm setting CPU star, I'm basically setting the clock frequency limit for all the CPUs together, so that whatever process is picked is always picked with the limited frequencies. So we can make this more flexible by just setting the clock frequency limit for like 1 CPU or 2 CPUs. We actually played around with that a little bit as well. So that is something interesting. So we can use this same thing to enable and disable the CPUs as well. So CPU0, for example, if you go in here, you can see that it has online or not. So if you go cat online, you see it is online because it's 1. So if you set this value to 0 using echo, like the same command that we used here, then you can basically disable this particular CPU, and you see that the phone's performance is again significantly deteriorated if you take down 3 cores. And it's not immediately visible if you're working with like one process, but if you work with like 3 processes, the phone becomes extremely slow and hard to work with. So this is how you can basically enable or disable the cores. So this part is already covered. So Parth will be speaking about how the enable speakers were enabled and like the work that we did behind enabling the drivers. However, another thing that I wanted to show you was the SMS messages from command line. So basically, like we ran these particular commands, and you can see that the numbers here have the +91 extension because we actually did not have SIM cards that would be compatible with the Nexus phone. So we basically use the SIM cards from the Indian phones that we used to use back there. And we put in each of these SIM cards, and to save cost, we texted an Indian phone from another and then put the SIM back into this to make sure that we were able to receive the message. So this message actually went out from my phone number into Parth's phone number, which was 981057710. And yeah, like with a fun message, obviously. And you can see that once that message was received, we were basically able to see it. Oh, right now the phone is it needs a restart because I set its clock frequency, but I did not basically reset it. I think I'd be able to show you the messages anyway. So here, if you can see, the first 2 messages were acknowledging the fact that we were in an international roaming situation. And the last one is the message that was received from my Indian phone onto Parth's Indian phone, which said, "Good evening, Mr. Bond." And yeah, we were also able to pick up those messages from the message history using this particular command, which is the cat local share history service, which had like a track record of all the messages that were received from different phones. So you can see that this particular message in between, the 9962562825513, was received from our phone when we were working on it yesterday before submitting the file. So that was for the SMS messages. And since the phone is lagging, I'd probably leave the loud part that we did for this to check the phone loudness with Parth as well. So that would be all from my side of the demo.
And now I'm going to talk about disabling the graphical user interface. Since we wanted like the battery to last longer, we wanted our power consumption to be minimized so that the IoT can be operated for longer duration. So in order to disable GUI, we follow the following commands. Start with initctl emit desktop and end, and then followed by initctl emit session end. These two were the commands that disabled most of the graphical user interface. We wanted to stop other processes so that again the power consumption can be minimized. For that, we'd stop the processes such as Bluetooth, proxy, manager, and things like that. For detecting the sound using command line, we use SOX command to detect the loudness of the recorded sound wave. So SOX is basically it's about like reading and writing audio files, and it can apply effects to them. It can combine multiple input sources, synthesize audios, and act as a general purpose audio player or a multi-track audio recorder. It also has a limited ability to split the input into multiple output files. So what we did was we built a bash script which will check the linear amplitude of the recorded sound, and if it is greater than the threshold value, we'll send the SMS to the user stating that a loud sound was detected.